My name is Mrs. Mburu. I'm presenting Mathematics Form 3 and a topic called binomial expansion. Our subtopic is expanding of using binomial expansion. Our objective is by the end of this session, the student should be able to expand using binomial expansion knowledge. Before we go to that, we will review what we did in Form 2. We expanded some terms, or we did some expansion of up to power 2. For example, we did a plus b squared. When we say a plus b squared means a plus b multiplied by a plus b. And then you're supposed to expand that, where you pick one, expand plus b, a plus b. So we will have a squared plus ab plus ab plus b squared. If we add them together, putting the like terms together, we'll have a squared plus 2ab plus b squared. We did that in Form 2. We can as well expand a plus b to power 3 or cubed. So we will have, this one means a plus b squared, a plus b. And because we have already done a plus b squared, we already have it. This a plus b squared is a squared plus 2ab plus b squared. Now all these we multiply by a plus b. So we will have what? We will have a multiplied by a squared plus 2ab plus b squared plus b. We multiply with a plus b squared so this one will give us a cubed plus 2a squared b plus a b squared plus a squared b plus 2ab squared plus b cubed. Putting them together, we will have a cubed plus 3a squared b plus 3ab squared plus b cubed. We can as well deal with a plus b to power 4. So this one, we can pick the one for a plus b cubed. So we have a plus b cubed, then multiplied by a plus b. This one now becomes more complicated, but you can try to deal with it. So we'll have a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed multiplied by a plus b. If we multiply this, we will have a cubed plus 3a squared b plus 3ab squared plus b cubed plus b a cubed plus 3a squared b plus ab squared plus b cubed. So if we multiply all that, we'll be able to get it. And if we move on, we can be able also to do a plus b to power 5, which becomes more and more complicated. Now, to be able to solve this, the knowledge of binomial expansion comes in so that we can be able to get all the others which have higher powers. So now, I want to introduce to you binomial expansion knowledge to avoid all these complications that you can see on the board. Now, what is a binomial expansion? A binomial is an algebraic expression with two terms. For example, a plus 3 has two terms. We have a and 3. That is an example of a binomial. X plus y is a binomial. It has two terms. 2a plus b is a binomial. It has two terms. We have 2a and then b. We also have 2m cubed plus n squared. It has two terms. We have 2m cubed and n squared. So all those are examples of binomials. Now, for us to be able to use the binomial knowledge, we are going to use this, whatever we have done here. Let me first write the answer for this one. The answer for a plus b to power 4, if you expand that, you get a to power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to power 4 or b power that. Now we have those three, we have already expanded. Now if you look at all of them, for us to be able to solve them, we require something we call Pascal triangle, and we can start by what we have. In form 2, we say under indices, any number to power 0. If we have a plus b to power 0, the answer should give us 1. If we have a plus b to power 1, it becomes the same, so it is a plus b. Now, looking at that, we have already done a plus b to power 2, so I'll write a table here of the expression. We also have the expansion and its coefficients. So our first expansion was a plus b squared. Its answer is a squared plus 2ab plus b squared. If we look at its coefficient, the first one has a coefficient of 1, the second one has a coefficient of 2, and the third one has a coefficient of 1, b squared. The other one we did was a plus b power 3. The answer was a cubed plus 3a squared b plus 3a b squared plus b cubed. Its coefficients are, we have 1, we have 3, we have 3, we have 1. The last one we did is a plus b power 4. The answer was a to power 4 plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to power 4. Its coefficients are, the first one has 1, the second one has 4, the third one has 6, the fourth one has 4, and the last one has 1. We have, if we look at that, and if we write them here, we will have the coefficient. We have 1, 2, 1. We have 1, 3, 3, 1. And the one for a plus b to power 4 is 1, 4, 6, 4, 1. How do we get them? No, we already said that a plus b to power 0 is 1. So the first one for a plus b to power 0 is 1, because any number to power 0 is 1. Then we have the one for a plus b to power 1. We said the coefficients are 1 and 1. So here I can write 1 and 1. The one for a plus b now squared is the one we got 1, 2, 1. How do we get them? We can be able to develop or to come up with a pattern of coming up with them. If we look at all of them, they start with 1 and end with 1. All of them start with 1 and end with 1. How are we able to get these two here? If we add 1 plus 1, we get 2. If we add 1 plus 2, we get 3. 2 plus 1, we get 3. For this one, again, we can be able to develop for the 1 for a plus b to power 4. We have 1 plus 3, we get 4. 3 plus 3, 6. 3 plus 1, 4. And we start with 1, end with 1. So we have this, we call them coefficients. And these coefficients, we call them a Pascal triangle, which was developed by a French mathematician called Pascal. And we don't need to develop this. In our next lesson, I'll show you how to get them without having to develop them. Thank you. We meet in the next lesson.